Welcome back. I hope you've got your notes handout with you. About to start talking about greatest common factor using prime factorization. In 3.3b, we'll talk about finding the greatest common factor using the ladder method, but you actually need to know both ways. Well, first let's talk about what a greatest common factor is. You know what a factor is. So greatest common factor is the largest or greatest value common to two or more whole numbers. In other words, it's just the biggest number that divides evenly into two or more whole numbers. Simple example, 2 and 10. 2 is the biggest number that goes into both. 24 and 108, 12 is the biggest factor that divides evenly into both. Some are really easy to do like this, and then some require some other methods. One way that you can do it is to list. So you can make a list of all the factors and then just look for the one that is the biggest that's common. The disadvantage is it's kind of tedious, especially when the numbers are big. It's easy to make a mistake, and it's just not a good use of your time. Advantages are it's very straightforward. It's easy for students to understand why that's the greatest common factor. It is really good to use as an alternate method to check your answer. When you work a problem two different ways and you get the same result with both methods, then you're confirming your answer. So down here, I listed all the factors of 56 and 180. You might recall we did all the factors of 180 in our previous lesson. But if you just look along the list, once you get to 2 right here, you really, there's 4. 4 is common. And none of these other factors, 7, 8, 14, 28, or 56, are down here. So it looks like 4 is the largest one that they have in common. So the greatest common factor would be 4. Now this method, while you can do it to check, it's not going to be one of the methods that I ask you to use on an assessment. So let's move over to prime factorization. That's on your next page. We've already learned how to write the prime factorization for a number. So once you do that, there's just one more additional step. So you're going to write them in exponential form, just like we talked about previously. Here's them not written in exponential form. Red, no, bad. In exponential form, thumbs up, happy, good, green. 56 is 2 to the third times 7. 180 is 2 to the second times 3 to the second times 5. I like to write them one on top of each other like this. Remember, always put the factors in order from least to greatest as far as the base is concerned. You're looking for what these have in common. Well, this one has 2 to the second, and this one has at least 2 to the second. They don't have 2 to the third in common because this one doesn't have enough 2's. But after that, nothing else is really common. So the GCF is 2 to the second. So you're actually using the least power of all common factors. In this case, excuse me, there were 2 common factors, 2 times 2, or 2 squared. So you want to simplify. You would not leave your answer as 2 squared for the greatest common factor. And that's all there is to it. So finding the GCF is actually, using prime factorization is just going to give you more practice with prime factorization. So you might try this next example number 2 by yourself if you feel super confident. If not, just keep watching along with me on the video. We'll do this one, and I'm just going to use the ladder diagram instead of the factor tree for the prime factorization. So I've got 64. And remember, I have to come up with a prime number that goes into 64. So I'm going to use 2. That goes 32 times. And again, I have to come up with another prime number. Well, that's 2. And it looks like I'll just keep dividing by 2. Another 2. And another 2. And remember, you have to keep going until you get 1 at the very bottom. So we've got 6 2's right there. So I'm just going to come over to the side and write 64 equals 2 to the 6th. And now let's do 80. Again, you can do the factor tree. I'm just trying to do another example using the other method. It's not really another method, it's just another way to write out the prime factorization. So I'm going to start off with 5 this time. I know 5 goes into 80 because it ends in 0. And it actually goes 16 times. So for 16, I'll have to use a 2. That goes 8. And for 8, I'll have to use 2. For 4, I'll have to factor out 2. You have to go one more layer here until you get a 1. If you don't go all the way down to the 1, you're going to be missing a 2, and that's a problem. So let's write 80 equals, so we've got 4 2's, so we've got 2 to the 4th. You can use the multiplication dot if you don't prefer the parentheses, times 5. So the GCF, greatest common factor, well, they have some 2's in common, but they both only have 4. That's what they have in common. So 2 to the 4th, or the least power of your common factors, is your GCF, and 2 to the 4th is 16. And this is exactly how I would expect you to show your work. Factor trees or ladder diagrams, write your numbers, list the prime factorization, write GCF equals, and write down what it is you're multiplying together to get it. In this case, 2 to the 4th. Hopefully some of you are already learning some of the powers of 2. All right, so stop the video, work the next one, numbers are a little bit bigger, and then come back to check yourself. All right, well, take a minute to look over what I've done. 148, you could have started with 2, but I started with 4 because I used my divisibility rule. 48 is divisible by 4, so I knew this number would be as well. And 136, same thing. Wrote my prime factorization over here. Sorry, I'm still yawning. 2 to the 2nd, and this one has 2 to the 3rd. So all they have in common is 2 to the 2nd. So 2 to the 2nd, which is 4, is your GCF. And I'll see you next time, and we'll learn another method for finding the GCF called the ladder method.